right? So with this, we complete this chapter 1. So let me, in the next 10 minutes, let me take you through from first slide to the last slide. So I hope we have, right, so we have studied the definition of database. Database is a collection of related data. So DBMS is a software that is used to define, construct, and manipulate a database. And you need to know the objective of any commercial database management system: to store and retrieve the data in an efficient way, right? So the objective of any commercial database management system is to store and retrieve the information in a convenient and efficient format, right? So the first topic we discussed in chapter 1 was that the limitations of file processing system and the advantages of database management system, right? So data in file processing system, we have inherent disadvantages like data redundancy, and which leads to data inconsistency, right? Since data redundancy refers to duplication of data, and if multiple copies of the same data that do not agree, we have this data inconsistency. We have difficulty in accessing the data, data isolation, integrity problem, right? So integrity problem has been solved in database management system, right? So I can enforce a lot of integrity constraint, like a student should register at least 6 theory courses and 2 lab courses every semester. Sorry, a student should register 6 theory courses and 2 lab courses every semester, right? The pass mark for a particular course is going to be greater than 40 marks, and so on, right? So it is possible for you to have multiple component integrity constraints in that involves several data items from different files, right? Right. So right, I have a call. Right, here you all know about this atomicity problem, right? So atomicity problem exists in file processing system, which is taken care in DBMS system, right? A transaction should occur completely or not at all, and it's taken care by this database management system component, right? So we have this we have a component in DBMS hardware to take care of this atomicity problem, right? So we also have some concurrent access anomaly in the case of file processing system, when multiple users try to access the same variable. So this again is taken care in DBMS. Security problems, we discussed about views granting different access rights to, right? You are going to create virtual tables to give different perspective view of the same database to different types of users. So we were able to enforce the security. We were able to identify the security issues, and you can sort it out, right? So again, DBMS, the second topic you need to know is like a schema: physical data independence and logical data independence. So for that, you need to know what is meant by physical level, how data is stored in a disk or in a file, and what are the data structures used to represent the data. You need to know about logical level, what relationship exists among the data. View level, right? So you need to know what's the difference between physical data independence and logical data independence, right? So physical, I should be able to change the physical storage structure of a database system without causing the application programs to be rewritten. It's known as physical data independence. Whereas logical data independence means I should be able to make changes at the logical level. I should be able to alter the structure of the database without causing the application program to be rewritten, right? So that's about physical data independence and logical data independence. So here the third topic is that you need to know about the different data models that are used to represent the data, right? The most popular model is used in all the commercial DBMS is going to be relational model, where we are using tables to store the data and tables to represent the relationship between the data, right? So all the commercial database management system, they use this relational model. So ER model will extend next in the next chapter. So ER model is used to represent the schema design of a database. So entity is an object of interest in a system, and attribute is a property of entity, right? Attributes are used to describe the entity, and there exists some relationship between the participating entities, right? So we also discussed about object oriented relational model, which combines the features of both object oriented programming paradigm and relational programming paradigm. And finally, we were using a semi-structured data model. So XML is a popular language used for representing a semi-structured data model, where individual items of the same type may have different set of attributes, right? So we have students. So for different students, I have different set of attributes. I will be able to store the contact number of a student in an XML file. For another student, I'll be storing his email ID, right? So different variables may have different set of uh, uh, different attributes. It's known as semi-structured data, and I will be able to represent semi-structured data in a better way using an extensible markup language, right? So then we discuss something about the basics of DDL, DML, and DCL. So DML is used for inserting records or information into a database, updating information from your database, deleting information from your database. We discussed about this procedural DML and non-procedural DML, right? So data definition language is used for schema definition, right? So the output of DDL is placed in the data dictionary, which is also called as metadata, data about data, right? So DDL, you would have also explored the different constraints: domain integrity constraints, referential integrity constraints, and assertions, right? So ER model is there, and UML is used for representing ER model. And we had some introduction about normalization. So normalization we have discussed in the beginning to avoid redundancy in data storage, and to avoid the different types of anomalies like insertion, deletion, and update anomaly, we go for normalization. So right, in unit 1 or in chapter 1, the essay type question is going to be a DBMS system structure, right? So if you would have seen any old question papers, then we have this essay type questions where students will be asked to state the architecture of a database system, right? So they will be asked to explain this storage components. So data file to store the actual data, indices for quick and fast retrieval of data, data dictionary, metadata, data about data, statistical data, right, which contains some statistical operations on the data. You have this authorization and integrity manager, right? And you have this transaction manager. So transaction manager takes care of this atomicity problem, right? Authorization and integrity manager, it checks for the authority of the user to access the data, and integrity checks for the integrity constraints, right? So you have a file manager, buffer manager, right? So DDL interpreter, it is used to interpret data definition language statements and convert it into data dictionary, right? uh, so you also have a DML compiler and a query evaluation engine. Finally, in the top tier, we have the different types of users who are going to interact with the system by means of either a query-based interface, or by means of a form-based interface, or by means of some uh, sophisticated users. They interact with the system by means of query tools, and database administrators who interact with the system by means of administration tools, right? So this is a essay type question, and you are expected to know the architecture, DBMS system structure, right? So this, it is an important essay type question. If you have some right theoretical uh, paper, we have this essay type questions, right? Then finally we discussed about this two-tier architecture and three-tier architecture in today's class, right? So basically you have a client is a consumer of services, and server is a provider of services. So you have an application program that runs in the client side that can directly connect with an database system by means of some APIs like ODBC, JDBC, OLEDB, and so on, right? So here the limitation is it is used only for small applications. So whenever you need to go for large applications that can be deployed in the World Wide Web, we go for this three-tier architecture, So in the case of three-tier architecture, the client communicates with the application server through a form-based interface. Right here, the client communicates with the application server through a form-based interface, and the application server in turn communicates with the database system to access the data. Right. So data definition language, I think there is some repetition. Right. So we have so what can be done in data definition language to define the database schema. So you can enforce different constraints like domain integrity constraints, referential integrity constraints, assertions, and authorization also can be permitted in DDL. And we have some introduction to data warehousing and data mining in today's class. Right. So data warehouse is a subject oriented, integrated, time variant, non-volatile collection of data for decision making in an organization. So data mining refers to the process of knowledge discovery in databases. So it is the process of semi-automatically analyzing large databases to find out useful patterns. Right. And finally, the functionalities of a database administrator. He is in charge of schema definition, changes in physical organization of schema, granting authorization for data access to different users, and it performs routine operations like periodically backing up the database, ensuring that enough space is available in the disk, and finally monitoring the jobs so that the performance is not degraded by very expensive tasks submitted by some users. Right. So this completes chapter 1. Right. So in we have 2 more chapters for unit 1. Right. So I thought of starting with a new chapter in the next class. Right. So the presentations is available in your course materials. You can very well go through it. So I will share you the ebook if you don't have access to it. Anyway, it's a pirated version, and I feel bad about sharing the ebook with you. Right. So if you are able to get the ebook by yourself, it is well and good. Else, like I can give it through your class rep. So that's it for today's class. So any questions from the participants? Right. So next class we'll study about relational algebra. So relational algebra is the base for this relational model. So all the SQL statements are based on relational algebra. So we'll next class we'll study about relational algebra chapter 2, which serves as a basis or foundation course for this relational model. Right. So that's it for today's class.